Okay, Year 7, welcome to solving geometrical problems. Today we are going to combine all of the information we have learnt so far in order to solve some pretty tricky problems. So you need to have a heading in your rule book, solving geometrical problems, and you need to write the following down. When we're solving geometrical problems, okay, I need you to write this down for me, please, these words here. Some geometrical problems are a little bit tricky and they require a combination of steps. So not just one step, but a combination of a few things before a solution can be found or before we can come to an answer. Sometimes we have to look at a problem and think, what do I know about this? And what different pieces of knowledge could I apply in order to find the answer? So sometimes we just have to look at a problem, sit back and think, okay, this is a bit tricky. What do I know about this diagram? What do I know that's in this problem? And how could I use that to come to an answer? Okay, so we're going to have a look at a few different examples. We're going to look at two main examples today. But this needs to be written and a heading needs to be solving geometrical problems needs to be in your book. So let's have a look at example 1. Okay, you need a little subheading that says example 1. Okay, and in example 1, we are going to have a look at this. So example 1 needs to be written down. Okay, you also need to draw this diagram here. Okay, so it might be a good idea to pause your video tutorial at the moment so you can draw this diagram down. Okay, you should have the diagram drawn down. The next thing you need to do is you need to write down next to it, find the value of A. Now, it's a little a here, so when I look at a diagram, I have a big A and a little a. This is the one I'm after. This little guy in here is the one that I'm after. Now, let's have a look. This is a bit tricky. I don't know what that answer is to A. There's nothing around it. There's nothing here, or that's not really helpful. There's no measurements there. I don't know what to do. So let's look at the diagram. What do I have? Okay, let's not start with what I don't have. Let's start with what I do have. What do I have? Okay, I've got 170 here. I've got this little box in this side here. Okay, I know that little box means 90 degrees. So I know that this is 90. That's 170. Okay, is there anything I can see here? Well, hold on. Let's have a look. If that's 90 and that's 170, I do know that altogether all of that equals 360 because it's a revolution. Which must mean that my D in here, or the D where the vertex is hitting here, must be part of that. Okay, so okay, so that's saying that this angle here, angle EDB, or this part in here, must be 360 minus 170 minus 90. So I'll write that down. Angle EDB must equal 360 minus 170 minus 90. And if I work that out, I come to an answer of 100. Which must mean D in here is equal to 100 degrees. Now, let's have a look. Is there anything? Okay, well, that helps me out with D. Is there any relationship between this here and that there? If I rotate my shape, whoops, this will look funny on the video tutorial, but if I rotate my shape here, I notice that this shape is making an F, which must mean that this angle here and this angle here are corresponding. And I know that corresponding angles are equal. So if D over here is equal to 100 degrees, it must mean that A over here is also equal to 100 degrees. Now guys, that's a tricky problem. But did you see the way that I was talking about it, the kind of language that I was using just then? I was humming and hawing and going, That's what I want you to do. I didn't immediately go, oh, okay, A, that's corresponding to D, and D is in a relationship of a revolutionary angle, because that's crazy. You wouldn't be able to see that. It's a matter of looking at the problem, humming and hawing, seeing what you know, and seeing if you can use that in order to solve the problem. There are multiple steps, not just the one. So, let's look at the next example. Okay, now, what have I got here? Oh, gosh, this looks tricky. Okay, I've got a parallel line and a parallel line. Okay, if I've got two parallel lines like this, that's helpful, okay? And again, it's asking me to find the value of A. So it's asking me to find this little guy in here. Now, the measurements that I have are 60 and 70 degrees. What can I do with this? Oh, okay, well, there's two parallel lines going like this and this. That in there, oh, look, hold on. That angle there and all of that. All of this are co-interior because they're making up that C shape. Okay, so if they're co-interior, I know co-interior angles add up to, what was it, 180, that's right. So, that's pretty cool. That must mean that this angle here, A, B, C, or all of this, would equal 180, subtract angle DCB, or the 70 degrees here. Okay, so I'll look for this one, angle ABC, or this angle in here. Let me just delete that. Get rid of all this diagram. Okay, so this angle in here, angle ABC, is equal to 180, because altogether all of this is 180, because it's co-interior, subtract 70 is 110. Okay, all of that is 110, so all of this angle here is 110. Oh, I don't want all of it, I just want this guy. Okay, I just want A. If I just want A, if all of it's 110, oh, hold on, I've got this 60 degrees here. So I've got angle ABD, or this guy in here, equaling 60 degrees. So to find this little angle in here, or angle DBC, or A equals 110, which is all of it, subtract 60. Oh, that's super easy. That's 50 degrees. Again, listen to the way that I sounded that out. Listen to my thought process. I did that out loud for you guys. That's the kind of stuff I want you to be doing. Out loud, thinking, this problem's tricky. I don't exactly know how to get to the answer, but these are things about this problem that I do know. And I can use these things in order to find the answer.